In the last video, we implemented a form to create new bank accounts. Today, we will submit those form values to the backend using tools like Axios and React Query. Also, we will define Next.JS API route to handle that post request, and finally, we will insert that into the database. As you can see, as of right now, on submit, we only are just console logging the values. There is no backend API calls, no database inserts, nothing. So the first thing we will need to do is to make a HTTP request to our Next.js backend. For HTTP requests, we could be using like default JavaScript fetch methods, but I always like to use the library called Axios, which is a promise-based HTTP client for Node.js and like the frontends itself, mainly because it's a promise-based and it has a lot more features, like you can set some global configurations so that you don't need to repeat yourself for each and every request. So let's go ahead and install it. All right, it was installed. Now we can create an API service, which will be used for all HTTP requests. So let's create a new directory for our services. Let's call it services, just like that. And inside of it, let's create a new TypeScript file called api.service.ts. All right. In here, we can import Axios from Axios, which we just installed. Next, we can say const API equals axios.create, which will create an Axios instance. And we can provide a variable called base URL. And for Next.js, the value will be /API. And of course, let's export this API instance. Now let's create one more service, which will be dedicated for dealing with bank accounts. So let's say bank account.service.ts. So we need a function for creating a bank account. So export const create bank account. It will be an async function, which will accept a bank account as a parameter. We will define types in a second, and it will return also a promise of a type which we will create in a second. So inside of the function, we can say await API, which we import from our newly created API service. And then we can say post, because the post method is usually used for creating entities on the backend side. Now we need to provide the URL. So let's say const URL, and it will be /bank accounts. So api.post URL and pass a bank account object. So this will return a response from which we can take a data object and return data. So actually we could even do it like this. So this create bank account function will be making an HTTP request to our backend endpoint, which we will be creating in a few seconds, and will return a newly created bank account. So now we can define the types. Let's create one more directory for the types, because we will need a bunch more for transactions, for categories, and similar stuff. So types. And in here we can create bank account.types.ts. So in here we will need a couple things. So for the types, we will also use Zod library, which will help us both in the backend and in the frontend. So let's say export const create bank account Zod. It will be a Z object. Let's also import Zod. So import Z from Zod. As you remember, our create bank account needs to have an account number, which is a string, so z string, and balance. And for the balance, we still need to do a little bit more work, because when we will be using this, it will come as a string, but we want it to be a number. So we can use a z preprocess function, which basically allows you to do some transformations. So let's say balance, and that string we can parse float, balance as string, and let's define that it will return a number. Okay, so we have our Zod object, so now we can create our DTO object. So export type, create bank account DTO, and we will infer the type from our Zod object. DTO is data transfer object, which basically means when you are sending an object from the front end to the backend. All right, and also we need one more type. It will be just a simple bank account. And for this, we will be using Prisma provided types. So Prisma dot bank account get payload, and inside it will be Prisma dot bank account default args. To use the Prisma types, we of course need to import it. So we can go to our db.ts and let's adjust our import. So let's import Prisma together with the Prisma client. And also let's export this Prisma object. So now we should be able to import Prisma in here. So yes, let's add an import from server DB. Prisma types are quite a complex topic, so it would be difficult to explain like in a couple of minutes. But for example, if I would define a new object here, bank account with the type of bank account, we can see that this bank account will have account number, an ID, balance, and user ID, which basically comes from our database schema, which we created in one of the previous videos. I will link that video in the corner. So, okay, we do have our types. So let's come back to bank account service and let's replace those ugly any. So the parameter itself will be a type of create bank accounts DTO, and the result will be of type bank account. Our bank account service is complete for now, so we can go ahead and create the backend API itself. Let's go to Pages, API, create a new directory. As you remember, our URL was bank accounts, so we need to name it the same, bank accounts, because that's how the Next.js is mapping those. And in here we can create an index file, which will have a bank accounts handler and a sync function with the parameters of request of type Next API request and the response of type Next API response. And we can export default this bank accounts handler. But since we want to protect this API from unauthorized access, we need to wrap it with a with API auth required hook from auth0 Next.js with API auth required. And let's import that. So now this bank accounts handler will be called for all the API requests which are using this particular URL. Meaning post for create bank account, get for getting bank accounts, put for updating, etc. So to distinguish what kind of request is coming in, we can say that we want to take a method and the body from the request. Then we can do a switch statement. So in case it's post request, we will implement the creation of the bank account. And in case it's anything else besides the post, we can say default response status method not allowed and provide an error message that this particular HTTP request is not allowed at this point. Also, we can indicate which HTTP requests are allowed. So for the post itself, firstly, we need to parse the body of the request. So we can do const bank account equals create bank account Zod dot parse and provide the body as a parameter. So this basically will validate the body of the request in the backend, and in case you are sending like something not according to our defined Zod object, it will fail. And if the parsing was successful, we can insert this bank account into the database. So in this project, database operations are done in the repositories layer. So we already have a user repository, if you remember from one of the previous videos. And now we will create another repository for bank accounts. Bank account.repository.ts. And in here we can create a new function called create. It will be an async function. It will accept bank account of type create bank account DTO. Now we can import the Prisma. So import Prisma from eta server db. And inside of this function, we can say await Prisma dot bank account dot create. Now we will need to provide a data object with the fields we are sending from the front end. So account number, which we can take from our DTO, and the balance, same stuff. And also we need to provide the user ID for which this bank account will be created. So user ID, and let's add one more parameter to this function. So user ID will be type of string. So this will return our created bank account, and we can return it to our front end. So it will be return created bank account. But if you were following all the videos, we decided to save our bank account balance and all the money related fields in the database as cents. Therefore, when returning the created bank account from the database, we need to divide it by 100. So let's create a small transform bank account function, which basically does the exact thing. Takes a balance and divides it by 100. So instead of just returning it, we first need to transform it. And of course, we need to convert this balance to cents first, because otherwise it will be confusing. Now that we have our bank accounts repository create method finished, we can jump back to the API itself and call this method. So let's say const result equals await. Let's import the create function from our repository. And we need to provide the DTO, which we parsed previously right here from the request body. And also we need to provide the user ID. And currently we do not have one. Since we will need this logic multiple times, I will create a small utility for the users. So I will call it user utils. And this small utility function will allow us to get the currently logged in user from the Next.js request and response using auth0 getSession method. So we first retrieve the session and then we return the user from that session. So let's jump back to the API. And now we can retrieve this user ID with await get user ID. And of course, we need to pass the request and the response objects. And then finally, we can say that response status is HTTP OK, which basically means 200. And let's return this newly created bank account via JSON and pass it to the JSON function. And we also, of course, need a break in our switch statement. So from the backend side, we already created a bank accounts API handler, which will handle the post requests for creating bank accounts. And we created a repository which will actually insert that bank account into the database. Now we need to call this API from the frontend. And if you remember, we already created a create bank account service in the frontend side, which calls this post request, but we haven't called it from our bank accounts form. So technically, what I could do is await, create bank account, imported from the service. But in that case, I would need to manually handle all the states related to the HTTP requests, meaning if the request is still loading, whether or not there were errors, I would need maybe to cache the data by myself. For this reason, on the front-end side, for like dynamic data, I always like to use React Query from the TAN stack. And that's what we are going to introduce in this project as well. So we can open up the documentation for the TAN stack query installation instructions. So the first step is npm install TAN stack React Query. Let's go ahead and do that. All right, the installation is done. Let's check the quick start. And basically what we need to do is firstly create our query client and wrap the entire application with a query client provider. Let's open app.tsx, create a new query client. Let's import that from the React Query package. And also we will need query client provider. So now we can wrap our entire application with this provider, query client provider. Let's pass the query client and insert the rest of the application. And that's basically it for the installation itself. There is a lot more information in the documentation because React Query is very capable. It allows caching, infinite queries, paginated queries, retries, disabling, pausing, and many more. And in this project, we might be using most of the features, I would say. So for now, let's just close the documentation. And now we need to create a mutation for our create bank account function. So let's say const create mutation equals use mutation, which is a hook from React Query. And now we can provide some parameters. So the mutation function will be our create bank account, which basically means whenever we execute this mutation, React Query will call our service, which calls the backend, and the backend later on inserts into the database. Also, we want to provide the onSuccess handler, which will be called whenever the backend returns 200 success response. It will be a function which will have the result from the backend. So as you remember, we were returning the newly created bank account of type bank account, imported from types. And now what we want to do when the onSuccess handler is called. The first thing I would say, we should move this dialog closing in here. Next, I would like to show a success toaster component, which we will be installing in just a minute, and maybe something else, but I will cover that later. So now we can also handle the onError cases, and on error, we also would like to show an error toast. And I think we don't need to close the dialog because the user can retry the request. Okay, so we do have our React Query mutation created. Now we can call it in our onSubmit. So let's do create mutation dot mutate. and we need to pass it the create DTO. But as you can see, all we have is just the values from the form. So first we need to create the DTO itself. So it will be create DTO of type create bank account DTO. It will be an object. It needs to have an account number. So let's say values dot account number, and also we need a balance. Let's say values dot balance. As you can see, the TypeScript is complaining that the string is not assignable to a number, so we can convert it by using our previously created function convert currency to number and pass this balance in there. So now technically we have everything we need to be able to click the add button, enter the account number, balance, confirm it, the request will be sent to the backend. But as we mentioned here, let's first add a success toast and an error toast just for the visuals. So let's open the Shadcn documentation. Let's look for the toast, copy the installation. Let's install the toast. The toast was installed. The next step is to add the toaster component into the app layout. So let's open our app.tsx. Let's import the toaster and add the toaster in the JSX itself. Now to show the toast itself, we can import the use toast hook. So let's go to our bank accounts form. Let's import the toast somewhere here. And then we can use this hook. So inside of bank accounts form, let's say const use toast. And inside our onSuccess handler, we can call this toast function. We need to provide a configuration object, and in this case, the description will be enough. So let's say description, bank account was added successfully. And for the error toast, very similarly, toast. Let's provide an object. For this, we will say variant destructive. It will make the toast to be red. Then we say title. Something went wrong. And also a description that there was a problem with your request. So it's almost the time to test the whole workflow. But first we can open up the PlanetScale database console and double check whether or not this table is empty. Oh, I think it's just bank account. Yes. So as you can see, the table currently is empty. So let's go ahead and test our functionality. So I will click add. Let's say my first bank account with the balance, I don't know, $100. And let's click confirm. And as you can see, the toaster is displayed, that bank account was added successfully. The dialog was closed. And the database, if I would run it again, is also updated. Account number is the one we set, and the balance is 10,000 because we are saving in cents, not in the dollars. But there is one thing I don't like about this toaster, is that it stays up here forever. I would either need to click manually to close it, or in some place of the code call the dismiss function, which can be extracted from the use toast hook. But since we are using the Shadcn UI components and the toaster itself is from Shadcn, we have a benefit of having the source code of the component in our repository. So I can open the toast component, not the toast itself, but the hook. So use toast. And let's look for the toast function. So toast, a lot of results, so I will just do it manually. So here's the toast function. So what we can do is, for example, right here, set a timeout, which would call this dismiss function after, for example, I don't know, 5 seconds. So basically, whenever I will show a toaster in my application, it will automatically be dismissed after 5 seconds, and I won't need to do the dismiss action manually or in the code in every component I'm using the toaster. So that's really good that you can like modify the logic of the Shadcn components the way you like. So let's try again. Add new, my second account. Let's give it 101. Confirm. The bank account was added successfully and it should close. And yes, as you can see, it disappeared automatically. So that's really cool. So we can remove this one. And now we can think how we could simulate the error case. So we would see the example, how it would look. And one of the ways to simulate that is, for example, let's just provide a random API address. So the backend will respond with 404. So let's try. Confirm. And as you can see, the error toaster was shown. Cool. Let's revert that. There's also one more minor thing which we can improve. It's about the confirm button. We can adjust the disabled state. So for example, we want to disable the confirm button when the request is already being processed. So to do that, we can say createMutation. CreateMutation is pending. So this button will be disabled either if the form is invalid or the request is already being sent. And also we can show the loader next to the confirm text. So we can do createMutation. If it's pending, render a loader. So pay close attention to the confirm button. The loader is shown, the button was disabled as well. That's it for this time. Thank you for watching. Hit that subscribe button if you liked it. In the next video, we will be working on fetching the created bank accounts and displaying them in the Shadcn UI table.